Hello, and welcome to Math Lessons with Linda. Today's topic is special right triangles. This is part 2, and the right triangle we are going to talk about today is a 30, 60, 90 degree right triangle. If you missed the other one, we did 45, 45, 90 in a previous video. You may want to watch that first. So the idea of special right triangles is that we don't have to do as much work as we do with other triangles in finding the sides and the angles. So I'm going to label our 30, 60, 90. And since the degrees are all different, that means all 3 of the legs of my triangle are going to be different. What it also means is that the smallest angle is always opposite the shortest side or the shortest leg. And the bigger of the 2 acute angles is opposite the longest leg. And of course, our right angle is always opposite the hypotenuse. So I'm going to label the side over here across from the 30. I'm going to label it SL. That means that's my short leg. And then over here, the 60, I'm going to label as LL. That's my long leg. And then over here, we know this is the hypotenuse. So as before, I'm going to choose some values and I'm going to show you and verify why this works. So I'm going to say that my short leg has a value of 1. My hypotenuse has a value of 2. And my long leg has a value of radical 3. Again, I chose these numbers specifically because they are pretty small, easy to work with, and I'm going to use them in the Pythagorean theorem to verify this. So I would take 1 squared, that's my a squared, plus the square root of 3 squared, that's my b squared, and that should equal to 2 squared. So 1 squared is 1, radical 3 squared is square root of 9, which is just 3, and 2 squared is 4. So 1 plus 3 is 4, 4 equals 4. So this relationship that I constructed for the 30, 60, 90 works out. So here is what happens if you have other values than these. So the short leg is friends with the hypotenuse. That's how I call it. And their relationship is that the short leg times 2 is equal to the hypotenuse. So whatever the short leg value is, I double it to get the hypotenuse. So the opposite would work. If I had the hypotenuse, I would take half of it to get my short leg. The other relationship is that the short leg has with the long leg. So for the short leg, if I multiply it by radical 3, that's how I get the long leg, right? These are the only 2 relationships in this triangle. The hypotenuse and the long leg do not have any relationship to each other directly. So, what if we have a triangle and we need to figure out some sides? So 30, 60, 90 labeled on here. So let's start off and say our hypotenuse is 18, okay? So remember the relationship is with the short leg and the hypotenuse. The short leg times 2 is the hypotenuse, or the hypotenuse is double. So since I know the hypotenuse, I'm going to divide by 2. I'm going to take half of it. That means my short leg is 9. So I can go back, 9 times 2 is 18. This relationship works out. Now I need to get my long leg. And so to do that, I multiply my short leg by radical 3. I leave it in radical form. So 9 radical 3 is my long leg. If you want to verify this the first couple of times you do it to make sure you're getting the correct answer, you can take these values and you can use the Pythagorean theorem to verify, and it will work out, okay? So this is just a shortened method for these very special 30, 60, 90 right triangles that allows you to find measures without having to set up a trig equation or do the Pythagorean theorem every single time.